Hello friends, welcome to our YouTube channel. Today we will discuss, in this video we will discuss the second part of the Laplace transformation. It is my second video on Laplace transformation. Okay, I have given an introductory video on Laplace transformation and given some important formulas and the basics of Laplace transformation in my last video. Okay, let's proceed towards let's get started. Today I will discuss about two topics on Laplace transformation. First one is first shifting theorem or S shifting, and the second is inverse transformation. Okay, let's get started. So first topic, first shifting theorem, which is also known as S shift. Okay, more common name is S shift. Okay, let's see what the theorem says. Okay, the theorem says if Laplace transformation of f of t, any function, is given by f of s. Okay, if Laplace transformation of any function f of t is given by f of s, then by changing or by adding some values or some other things to this function, like this e to the power 8t, okay, and f of t, Laplace transformation of e to the power 8t f of t, by multiplying e to the power 8t in this function, it will be f of s minus a. Okay, if Laplace transformation of f of t equal to f of s, capital F of s, then Laplace transformation of e to the power 8t into f of t will be just f of s minus a. Okay, very easy proof, you can do it your own. Just simply put the total function. Let's take this in f of t in the place of f of t in the first formula. Okay, and you will get this result very easily. Okay, let's do it your own. If there is any problem, write in the comment box, I will prove it. Okay, let's do some examples and understand how it works. Okay, our first question, Laplace transformation of e to the power 3t into t to the power 5. Okay, find the Laplace transformation of e to the power 3t into t to the power 5. Okay, here our f of t is 2 to the power 5 and a is 3. Okay, so let's find out first. Our clue is Laplace transformation of t to the power 5. So by the formula n factorial by s to the power n plus 1, we have 5 factorial by s to the power 6. Okay, n factorial by s to the power n plus 1. Okay, it is 120 divided by s to the power 6. So Laplace transformation of a to the power 3t into t to the power 5 will be just, we have to replace s with s minus a, that is s minus 3, that is 120 by s minus 3 to the power 6. Okay, let's do another question. Okay, here is the question, find the Laplace transformation of e to the power 2t into cos 4t. Okay, here our f of t is equal to cos 4t. Okay, so our Laplace transformation of f of t will be s by s square plus omega square. S square, here omega is 4, so 4 square 60. Okay, so Laplace transformation of e to the power 2t into cos 4t will be just replaced by s with s minus a, so s minus 2 by s minus 2 plus 60. Okay, it is very simple, right? Sometimes we have to find the f of t. Okay, in this question, here there is a question: find the Laplace transformation of e to the power at plus b. Okay, here a and b are two constants and t is the only variable. Okay, here there is only one term and we have to find the Laplace transformation. Okay, we have learned the formula for e to the power a into a 80, not e to the 80 plus b. So let's do. Okay, here we can also write like this: e to the power 80 into e to the power b. Okay, so the multiply by multiplying this 80 plus b will be here. So we can just write this into this form. Okay, here there are two terms. This is our e to the 80 and this is our f of t. Okay, so Laplace transformation of e to the power b. Okay, this is a constant, so our Laplace transformation will be e to the power b into Laplace transformation of 1. So e to the power b by s. What is the Laplace transformation of 1? That is s. Okay, so this is our Laplace transformation of e to the power b. So Laplace transformation of e to the power 80 into e to the power b will be e to the power b by s minus a. This is the answer. Okay, very simple. Now we will do another concept. Hello friends. Now we'll discuss the inverse Laplace transformation. Okay, inverse Laplace transformation. Okay, inverse Laplace transform. Okay, if L of f of t is equal to capital F of s. Okay, if L of f of t is equal to capital F of s, then L inverse of f of s will be f of t. Okay, this is just the inverse. Okay, this is the inverse Laplace transformation. Our question will be find the inverse Laplace transformation of f of s. F of s will be any function of s. Okay, you have to find the its Laplace inverse Laplace transformation and the answer will be in t. Okay, let's do some example. Here this is our question. The find the inverse transformation of 2s plus 3 by s square minus 5s plus 6. Okay, let's do it. There are two methods to solve it. Okay, I will solve in the lengthy process and I'll say what is the shortcut process. Okay, so we have to make first the substitute. Okay, we have to make the some adjustment in this function so that it will be easier for us to trace out the its inverse. Okay, let's do one thing. Here there is a what square. Okay, let's make it a perfect square. L inverse, okay, 2s plus 3 divided by, like, let's make it s minus 5 by 2 whole square. Okay, this is s minus 5 by 2 whole square plus what will remain 6 minus 5 by 2. 6 minus 5 by 2. Okay, s square minus 2 into s into 5 by 2, that is minus 5s plus 5 by 2 whole square and minus 5 by 2 whole square 0 6. So denominator is both are same. Okay, next, okay, L inverse, that's what is the value, 2s plus 3 by s minus 5 by 2 whole square minus 1 by 4. Okay, let's make some changes in the upper side. Okay, 2s, let's make it 2s. Okay, minus 5 plus 5 plus 3. Okay, s minus 5 by 2 whole square minus 5. We just have to compute this into a known form. Okay, I am computing this in the hyperbolic trigonometric function. You remember that? Okay, L inverse L of cos hat is equal to s by s square minus s square, s by s square minus s square. Okay, so I'm just converting this. Okay, here this is s square minus s square 4. So in upper we have also do some arrangement that this will appear like that. Okay, here one thing, this is 2s, right? Here let's divide them, let's separate them. Okay, L inverse, and from this let's take 2 common. Okay, 2 L inverse s minus 5 by 2. Okay, by s minus 5 by 2 whole square minus 1 by 4. Okay, plus from here let's divide, let's multiply 2 and into 2. So 8 into 2, multiply 2 and divide by 2. Okay, 1 by 2. Okay, s minus 5 by 2 whole square minus 1 by 4. Okay, we have multiplied 2 and divided 2. Okay, this is L inverse. Okay, very simple. Now here, look here, it will appear like, okay, this will s minus 5 by 2 by s minus 5 by 2 whole square minus 1 by 4. You remember the formula of cos hat. Okay, Laplace transform cos hat is s by s square minus s square, and by the first subtracting theorem here minus 5 by 2. So our answer will be e to the power 5 by 2t. Okay, cos h, here a is 1 by 2. Okay, 1 by 2 whole square is 1 by 4 cos h t by 2. Okay, here 5 by 2t t by 2. Okay, that's 82 to 16 and to e to the power. Here also this is for sin h. Okay, e to the power 5 by 2t. Okay, for stepping theorem, and this is sin h t by 2. Okay, here a is 1 by 2, and this is the our answer. Okay, you can use also the method of variation of parameter, that is also very easy. I will use that in the next question. Okay, okay, this is the second question. Here f of s is equal to 1 by s minus root 3 into 1 s plus root 3, and we have to find f of t. Okay, by method of variation of parameter we will find this. So first let's do some arrangement here. Here f of s is equal to 1 by s minus, let's write this as this part. Okay, let s minus root 3 plus, we have no formula for this. Okay, but we have formulas for 1 by s minus a. Okay, which is e to the power 80. Okay, Laplace inverse Laplace transformation of 1 by s to s minus a is equal to e to the power 80. So we will just make it that form. Okay, this is s plus root 5, where a and b are constants. Okay, so by adding them, the denominator will be s minus root 3 into s plus root 3, but in the upper side this will be as. Okay, multiply here this and this, as plus root 5a plus bs minus root 3b. Okay, if these two are same, if for equating these two, so this will be 1. Okay, upper side also same. So by equating the coefficient of s in this side is zeros, and in this side this is a plus b is equal to 0. Okay, equating of coefficient of 1. Okay, here this is for constant, this is root 5a minus root 3b, and in this side this is 1. Okay, and these are two equations. We have to solve these two equations. Okay, finding a and b. By solving this equation, we have a is equal to 1 by root 5 plus root 3, and b is two simple equations. We have just to solve them. Okay, and b is also equal to 1 by root 5 plus root 3. So we have met this. I want to transform this. Okay, so there are two constants. So 1 by root 5 plus root 3 into s minus root 3. Okay, plus 1 by root 5 plus root 3 into s plus root 5. Okay, by finding the Laplace transformation of this, it will be by taking common 1 by root 5 plus root 3. Okay, this is 1 by s minus a, so it will be e to the power root 3 t minus, sorry, here it is minus. Okay, it is b equal to minus, so this minus e to the power root 5 t. Okay, this is our answer. Thank you. This is total from this video, and please hit the like and subscribe button. We will discuss further in the next video on Laplace transformation. Thank you. Goodbye.